More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at home. Real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at home is right for your child, visit mathnasium.com/at-home. Mathnasium at home, changing lives through math.
Hi everyone, and welcome back to Mathnasium Schoolhouse. My name is Sandra. I was just setting up my comments here, ready to see you guys. So if you're here joining us today, please say hello as always. Feel free to let us know what grade you're in, what brings you here. And as always, I'm interested in what brought you here as well. So what do you think about today's topic? So it's, of course, looking at, just reading the title, symbolic operators. So what do you think we're going to be looking at here? Or maybe instead of that, you can tell me what are some operators that we know about in math? What have you learned about in math class? What operations, I should say? That's probably the word you're most familiar with. Let you give me some answers, some comments for the next few seconds. See who else will join us today. Hello, hello, everyone that's joining us. So I'm just going to pull up my whiteboard here, and I'll write down some operations that we're definitely familiar with. We've seen them here on Mathnasium Schoolhouse, of course. We have addition. We've worked with that before. We have subtraction, multiplication, and division, right? And so what do we know about these things? Well, one thing we definitely know is that when we see them in a math class, right, if we see this, we know what it means for us, right? It seems weird. It's two lines intersecting each other perpendicularly, but we've been taught to understand what that represents, right? This is a symbol for us, and it means we're going to add, which means specifically if I have two numbers with this symbol in between them, I'm going to essentially put these together, and I could take out my counters if need be to help me understand better what that looks like, but I'm finding a total. For example, here it comes out to 2. Hello everyone, lovely to see you guys joining us here today. I see Cassidy, I see Kyle, hello. All right, we see also this symbol here, subtraction, and so when we have two numbers that have this symbol between them, let's even take the same numbers, 3 minus 2, or subtracting 2 from 3, I know I've been taught to understand what this symbol represents. It means I'm removing this from this amount from this amount, which means 2 subtracted from 3 leaves me with 1. But although this looks like it's just essentially a line, in mathematics I'm taught it represents something. It's a symbol that represents an operation, which means I have to do this to it. There's a rule associated with this symbol. And so that's essentially what we're looking at today, right? We're going to be using some of these operations that we're very familiar with. We know what it means to multiply, I hope, if we're joining today's lesson. And division, we know how to divide two numbers. We saw some of that yesterday too if you joined us for our Schoolhouse lesson. And today we're going to be just looking at different symbols. And they might not be symbols that are necessarily used in every math classroom or if you continue to study mathematics, but they are simply symbols that we're putting together with a rule. So let me show you an example. And just by the way, for those of you that have seen, is addition and subtraction operation? Yes, it is, exactly. They're all operations, right? We're doing something to numbers when we have those symbols in between them. I was just going to say, for those of you that follow our Facebook page, there was a worksheet that was posted a few hours ago, which has both follow-along pages, if you want to follow along with the questions I'll be working through today, as well as a practice page to just provide you with more practice after today. So go ahead and pull that up if you'd like to have those questions right in front of you, maybe on a separate tab. You can print them afterwards if you have access to a printer. Hello, Miranda. So, as I said, we're going to be looking at just some uncommon symbols, some that I haven't even seen before. And for all we know, they could be made up symbols, right? Made up symbols, but the fact is they represent a rule, and we're going to use those rules to play around with some numbers in our sample problems. Okay? Let's say, for example, this is going to be a very basic one, but let's say I'm teaching a class today and I come up with this symbol. Okay? Right now, to me and you, it means nothing. It looks like two square brackets and that's about it, but I have no idea what it means when they're side by side, back to back like this, right? But I'm going to tell you that when I have this, this means that I'm going to take your first number, let's say it's just x, and if we're here and we're in fact at a pre-algebra level, you would have already been working with variables, so this just represents one number for us. I'm going to take one number and add it to my second number, which I'm just going to call y. Why not? All right, so for example, if I have this, if I'm given something like this, this simply means this, right? I've read the rule. I know what this operation does. This is my new symbol. This is what we're going to be calling our symbolic operators. Some symbol that represents some operation or combination of operations. And we're going to follow those rules to work with the numbers we have. So I've taken these words and I've written them down mathematically what they mean to me. Okay? Which, you might look at this and think, okay, this is kind of silly because I already know that this is playing the role of this, which is true, which means that if I give you a sample problem like this, what do I do with it? I take x, which is my first number, and I add it, because this is what this symbol tells me to do, to add to my second number, which is a 6. And 4 plus 6 is 10. Okay? Let me give you a few more. Let me give you, in just a second, let's see if we can do this one. So I'll get you guys to try this out for me, so I'll write it out. What is this equal to? I'll give you a few seconds to try that out. You've never seen an x written that way before, yeah. So I'm writing it more so, less as an x like the letter x, more so like the variable x that you'll see in a mathematical notation format. Pre-algebra just means that if you'll be studying algebra next year, you'll be taking your pre-algebra course, possibly right before that. Typically is at level 8, for those of you asking. Okay, so what does this give us? I see some people showing up the answer already. Thank you so much. And that is exactly true. So I can take it step by step. And so since I know that this symbol for me represents essentially addition, 4 plus 6, we already found that out. Here, I have 3 plus 2, which is a 5. And for those of you that understand when you have brackets like this, it means simply multiplying. I am left with multiplying 10 times 5, which is 50, as you guys are telling me it is. Okay, and I see some of you are writing down 15. I kind of actually like seeing that because it means that we can actually speak to it, which means you by accident, maybe you just don't know that sometimes when you have brackets like this, you actually multiply the numbers and you are interpreting it as the square brackets, which is fair. It's the first time we're working with this. But it actually means that we're multiplying those two numbers, not adding them. So that's actually a very good mistake to make because it means we can speak to it. All right, so let me actually then show you another operation. We'll practice that and we'll get to some more complex ones because why not? So let's say I give you a symbol such as, bear with me here. Let's say I tell you this. Bear with me, I'm trying to draw a hexagon here. A very poorly drawn hexagon. You know what? Let's stick with a square. It doesn't matter at this point. I'm just creating a symbol. I could have drawn a triangle, whatever I wanted. But when you see a square in between x and y, or two numbers, what you're going to do is you're going to multiply the first and second number. Then you're going to subtract the second number and subtract 1. That is the rule I'm telling you to use when you have this symbol. Okay, so I'm going to box that up. You're going to remember that. And I'm going to pose a problem to you. Let me actually use my blue marker for this. What if you have 4 with a box and a 6? Take a few seconds to calculate that. What do we get here? What do we think? So just watch out. So someone is saying 6 sides, 4 sides. This has nothing to do with the sides of the square. This is simply a symbol I'm using in between two numbers. And when you have that case, you're associating this rule to it. Okay? So nothing to do with the square itself. 19, I believe that's super close unless I did my math wrong. I think you're off by just a little bit. Few more seconds to try that out. Yeah, I'm seeing it. I saw a question mark behind it. So let's see. So let's do this together, right? So let me use my green to just plug it in, plug all these numbers in, substitute, I should say, into these variables here. So I have my 4 is my x, and my 6 is now taking the place of the y here, which means let's substitute into this rule here. I multiply my first number by my second number, which means I'm going to have a 4 times 6. For those of you unfamiliar with this notation, I can have the dots represent multiplication. I could have the standard X symbol. I could have the round brackets as I had last time. But just so you know, that is multiplication that's occurring there. Minus my second number, which is a 6. And then subtract a 1 from all of that. So what do I get here? What is 4 times 6? 24. Subtract a 6 and subtract a 1. If I take 24 and I subtract 6, what do I get? I'll get 18, and I subtract 1, I'll get 17. So that is my final answer here. Okay. So just be careful with your order of operations. All right, perfect. All right, so I'm going to erase this. Let's do a few more of these simple ones, and then we'll get into some more rules. So I'm going to show you my PDF here, so hopefully you can see that nice and clearly on your screen. I have a portion of my worksheet that I made for myself, and we're going to answer these 4 questions together. Now notice there are some integers in here, so for those of you unfamiliar with them, you can skip them for now or try to follow along. Let's see what happens for number 1. Let me go down here. Now let you guys try out number 1 on your own first. So remember what that symbol represents for us, right? We're adding those 2 numbers. So what do we do there? If you remember, we take the first number and we add the second number. And because it's a negative, I'm just going to use brackets here to make sure I don't confuse it with the operation. And what do I get here? -4 plus a -3. -7. Thank you, Tracy. If that is the student's name. There we go. Very nice. So let's carry on to number 2. So they, of course, have, I believe it's a hexagon. Yes, it is. I used a square, but it's still going to represent the same rule. So again, if you don't remember it, I think I do. It was multiply the first number times the second number. So I'm just going to use brackets here. Then you subtract the second number and you subtract 1. Go ahead and tell me what that is. first you'd want to figure out the multiplication here, and I'll use my green for that. -2 times a -3 gives me a +6. I also want to take care of what's happening here. When I'm subtracting a negative, I can just treat that as adding the number itself. Oh, you're Cassidy. There we go. I figured. Right, and you said hello before earlier too. That's my fault. Great job, Cassidy. So what do we have? We have 6, and then we're going to add 3 and then subtract 2. What do we get? I'm not seeing it just yet. Oh, there we go. I see an 8 appearing. Beautiful. All right. Let's do number 3, and you can see we're now starting to get just the slightest bit more complex in that we're joining 2 of those rules together. So let's see how many of you remember the rules themselves. So we have, I'm going to write down, we're looking at number 3 here. What do we have here? 4 and a 6, and I can cheat a little bit. I hate to use the word cheating, but I remember that we actually did this previously together when we have 4 with those square brackets in between each other with the 6. Then we know that they were adding them, and we figured out that that was a 10. So essentially, I can just take that. I'll take my blue marker here, and I'll say that that is a 10. Okay. And I believe we did the 3 and the 2 together as well. We said that that was a 5. And I'm not going to draw a hexagon. I'll just draw a square. Unless I can attempt my poorly drawn hexagon. Why not? Better to see a poorly drawn hexagon than be confused with what operation you're working with, right? Remembering isn't cheating. I love that. That's so true. Just means I have an okay memory. Okay, so I have a 10, and then I have this hexagonal operation here with the 5. And what did that tell me to do? If I remember correctly, it was multiply the first by the second, subtract the second, and subtract 1. What do I do after that? Well, let's take care of it and remember the order of operations. So we have 10 times 5. I know that really quickly is a 50, so I can even write that here for those of you that need to see what's happening. Then I'm essentially left with 50 minus 5 minus 1. I can just work from left to right. 50 minus 5, 45. 45 minus 1 is 44. There we go. All right, and number 4, let's do this one. Let's see how fast we can do this one. We have 4 with the 2 square brackets and the 6. We remember that that is a 10. Wonderful. And then I have this hexagon here and a 2, and I know that that is to multiply the first with the second. I'm just moving between the dot and the brackets. Don't mind me. It's whatever my hand feels like drawing in the moment. I subtract the second, subtract the 1. Really quickly, 20 minus 2 is 18, minus 1 is 17. You guys are responsible for catching any of my errors in case my very fast math treats me poorly. So that's it. Okay, so that's essentially what we're working with. We're just going to practice a lot more now for the next few minutes together. And this is really where the follow along worksheet starts. So we're just going to be getting into some more operators. Again, the lesson of today is that whatever symbol you're posed with, you associate the rule with it, and you just work with the numbers substituting into that rule. That's essentially it, right? And you can think of the standard addition and subtraction, multiplication and division symbols that we use as just symbolic operators as well. So I'm going to move down on my PDF in just a second, and I'm going to show you, and actually maybe I'll show you here first. So this is just from the follow along worksheet. I know it's hard to see, which is why I'll pull up the PDF in just a second. But at the top of it, you have a bunch of definitions that are given to you. So if I even hold that up, I understand you can't read it, so don't worry about it. But when you eventually take a look at that, you have a lot of different operations here, or definitions, I should say. And so we're going to be working with the numbers down here to apply these definitions and find the result. All right, so I'm going to put that to the side. It's just for me to know what questions there are, and I'm going to pull up my PDF. So let's see here. Bear with me. So this is what I mean here. So you have a bunch of definitions here, so you can see some of the ones we've already worked with as the first one, and a few more. So I'll pull them up as needed, but let's take a look at, let's jump to number 2. Well, we can jump to number 1 really quickly. It's just that we've already worked with it, right? So this is just simply telling us to take the first number times the second number. I'm just going back to the rule that's here, right? When we have the hexagon in between, I take the first number, I multiply by the second, I subtract the second, and I subtract a 1. I'm going to leave that there. You guys can help me find that answer. And let's put together number 2 so you guys can help me figure that out as well. We're being introduced to a new symbol here. So it looks like it's a circle. It's a circle with a line going down the middle. And what do we do with something like that? Well, I'm going to look at my definitions just at the top here. Try to find it. It looks like I found it. So it looks like when I have an X with the symbol between that and the Y, I take that first number and I add it to 4 times that second number. So that's the rule that I'm using here, which means if my numbers were 3 and 3, what do? Well, I take my first number, which is the 3, and I add it to 4 times my second number. Again, I'll let you guys take a few seconds to help me out with that. Let me see if there's any comments here. So you guys have some great questions. I see my helpers are helping me out. I really appreciate that. So some of the questions were, can the brackets in the hexagon change? Like the hexagon can mean subtract and the brackets can be like multiply. Yeah. And I love the answer that was given. That's exactly true. So in this PDF and in this follow along worksheet, we as Mathnasium have decided on certain rules for these symbols, but maybe your teacher in your classroom in September will give you this symbol and say there's a different rule associated to it. So whatever rule you know that symbol represents, that's the rule that you're using, which is why in math, we always have to define what we're working with, be very precise. But that's a very good question. Okay? Sometimes they will mean different things, but if I go back to my original message, we know that the addition sign, the subtraction sign, multiplication, division, those are standard symbols that we've decided in math. We decided as a community altogether that these will forever mean finding a total, finding a difference, and so on. What if you put the wrong symbol and you do the wrong equation? What will happen? Well, you'll get a different answer, yeah. So sometimes my symbol will mean something different than someone else's, so we'll get a different answer, which is fine, but I did it correctly because I used the rule that I was told to use. But great questions. I like this. I love a good math conversation. It means we're really thinking hard about what we're doing, and we're not just doing it because someone told us to. We really want to understand what's happening behind the scenes. I see a bunch of 15s here. I like it. Let's see where 15's coming up from. Well, if I have 3 times 3, that's a 9. I subtract a 3 from that. That's a 6. I subtract a 1. That's a 5. And if I go down here, you guys, I think, are telling me 15 to this one because 4 times 3 is 12, and if I add a 3 to a 12, I get a 15. Beautiful. Let's carry on with a few more on this page before we get into a bit more complicated ones. So I'm just going to scroll through my PDF here. Let's go down to 3 and 4, some new symbols. So let me write them down first so we don't forget them. So we have a 3 with another funky symbol there, and it looks like it's a square with a circle and a triangle in it. And then another 3 here. We'll take a look at what that symbol means in just a second. And what if I had a 3 and it looks like a square and then a rotated square within it? So I'll let you guys help me figure out what these rules mean. So I'm going to scroll up to the top here. So the first one looks like, if you see it there, it's at the bottom of the list. And what does that rule tell me? Well, it says you take your first number and you add it to 5 times your second number. Pretty easy to do, I'd say so. I take my first number and I add it to 5 times my second number. What is that? Well, 5 times 3 is 15 plus 3 is 18. Right? Nothing too hard here. Once we know the rule, it's pretty easy. And if I have a 3 and a 3 with this symbol in between, what do I get? I have to take, it's at the top right there of the page, I have to take my first number. I almost wrote an X. I have to take my first number, which is a 3. I have to divide it by my second number, which just happens to be a 3 as well. And then I take the square of all of that. What do I get from that? Let me just take a look at the comments here. I don't miss anything. Oh my gosh, you guys are having a Harry Potter conversation over here. Very nice. What do I get here? And just as a side note, the reason why mathematicians, so we're working with fairly easier symbols here, but sometimes mathematicians purposefully use symbols because they don't want to write out this whole thing, which means when a rule is super, super long, you have to add this, you have to multiply that, divide that, subtract that, and you have to do it multiple times. Sometimes instead of writing that out so many times, just uses up too much time, annoying, it uses up paper or whatever else. So we just, as mathematicians, we just say, you know what, this symbol is going to represent those 5 bajillion steps. I'm just going to write it as one thing. Whoever encounters this is going to know it represents those 5 bajillion steps, and that's what we're going to do. So sometimes it's super helpful to create these symbolic operators so you don't have to keep on writing out those long, long, long operations. Okay? And so maybe that helps answer your question, Cassidy. Why do the symbols matter? Because of that. Okay, so whatever, if I'm a mathematician writing out some sort of formula, something I discovered, let's say, I don't want to keep on writing out all those steps, so I'm going to say, you know what, from now on, anyone that sees this symbol, it means this and this, and that's all that I have to write. I just have to draw that out. And I see 1 appearing a bunch of times, and I apologize for not addressing that sooner. That's exactly right. I take my 3, 3 divided by 3, 3 goes into 3 just once. 1 squared is the same as 1 times 1, which is just, of course, a 1. Google said pre-algebra is 6th and 7th grade. Yeah, it really depends on what school I believe is in, but some of my helpers can help me out with that. I'm going to erase this and scroll down to the last few questions in this PDF. So we have here new operations that are popping up. So I have number 5 uses this funky, it has a box with max written in it. And number 6 uses, again, the same numbers, another box with exp written in it. We'll see why that's the case right now. So if I scroll up, let's see the box that has max written. Aha, it's this pretty lengthy one, right? This is where a symbol is super helpful. So let's try to read this together. For some of you, this may be a little bit complex, but I promise once you get a hang of it, it's very easy to read. So when I have an X, or I have a number, in this case 3, and then I have this symbol in between the next number, the first number and the next number, second number, the result will be one of 3 options. The result will be the first number if the first number is bigger than the second number. So let's ask ourselves that. Is 3 bigger than 3? 3 is the same as 3, so that's not the case. Okay, fine, let's move on. 2 numbers separated by this symbol will be equal to the second number if the second number is bigger than the first number. Is that the case? No, we just decided, we just figured out that they're the same number. Okay, fine. So it must be that the third case holds true. Let's confirm. 2 numbers separated by this symbol is equal to 0 if the first number equals the second number. Yay! We said 3 is equal to 3. Pretty obvious to us. So that answer is a 0. Let's check out the comments here. Yeah, in addition to what I said, sometimes mathematicians want to use a faster symbol to represent more operations. Sometimes it's just fun. Totally agree. All right. So let's see the second one here. I hope that made sense for the max symbol. Let's move on to the second symbol there, which means I just need to scroll up the slightest bit. So let's make sure that's showing up for you. Okay. So what does it mean here? If I have two numbers separated by this symbol, it means, let's open up a bracket just because that's what it tells me to do. I take my first number and I multiply by 10 to the power of my second number, which just happens to be a 3 as well. Let's practice our math skills here. What is 10 to the power of 3? I'll let you guys help me out with that. What's 10 to the power of 3? Max reminds you of coding if statements. Love that observation. Very good catch. What is 10 to the power of 3? I'm going to wait for someone to help me out with that. Powers of 10 are super fun to work with because they could be really easy when you notice a pattern. What happens when I get 10 to the power of 3? I'm glad this is fun. I really like this kind of stuff too. I like when we can take some of the standard lessons that we learn in the math class and expand it and extend it to different areas. 1,000, thank you, thank you. Thank you, Cassidy and Rebecca. That is exactly true. So if I have 10 to the power of 3, one pattern you might observe is that you take 1 and you write, I guess, this many zeros behind it. So 1, 2, 3. Okay. So we would have 3 times 1,000. What does that give us? Well, if we know anything about multiplication, it's just repeated addition, which means we're repeatedly adding 1,000 3 times. So that gives us 3,000. All right, let's do a few more. Let's maybe finish this page and then I'll jump to the last page. Let's finish with some of these. So the last 2 questions on this page here have, again, new operations. So let's see here. We have a really cool one that has a triangle. So I'm going to just write it out so we don't forget it. We got a 2 here, a 1 here, and a 3 here. We'll see what that means in just a second. And here we have a box with 3 dots, and beside each dot is a number, 2, 3, and below that dot is a 1. Let's see what we do with each of these. I'm going to just go up to my definitions. And when I see a triangle, I'll stop. Aha, I see it. So just be super careful with what Y represents, X and Z, or Z. So let's see here. Let me use a different color, actually, just to not get confused with what we're working with. So when I see this symbol, this triangle, and I have numbers at each of the vertices, I take my X and just note that the X is at the bottom vertex. So this guy here. So the 3 is my X. I'm going to write that down. It's raised to the power of Y, and Y is just at the tip of the triangle. So it's raised to the power of 2. Just going slowly, step by step, because this is new for me. I want to make sure that I'm really substituting the right numbers in. Then I take my Z or my Z value, which in this case is a 1, and I raise it to the power of Y again, which means it's raised to the power of 2 again. What does that give me? I'll let you guys do that math for me. What do we do here? I apologize, Sierra. What do I get here? I'll wait to see this answer. So let's take care of the exponents first. I will take 3 to the power of 2, which hopefully you got 9 from that. 3 times 3. Then I take 1 to the power of 2, which if you don't know the patterns yet with 1, that's fine. You can still think of it as 1 times 1, which gives you 1. And 9 plus 1 is 10. Oh, just be very, very careful. It's not multiplying 9 times 1, it's adding 9 plus 1, because this operation, or sorry, this symbol tells us to add those 2 values. So that's the right answer there. And let's carry on to this bottom one, which means I need to find that definition on my page. So let's scroll down until I see it. It's a box with 3 dots, just at the bottom there. So what do? Again, just being very careful with which numbers I'm using for every variable. I'll take out my blue marker and I'll see I take my x value, which in this case is my 2. It's on the left side of the box. I divide it by my y value, which is just at the bottom, and I raise it to the power of 3. And I think we saw something like this before. 2 divided by 1, well, there are 2 1s within a 2. That's just a 2. I raise it to the power of 3. If you don't have that yet in your mind, if you haven't worked with this enough, 2 times 2 is 4, multiplied by another 2 is 8. For some of you, you might have been able to effortlessly recall that. Perfect. So let's jump. I'm going to jump to a new page in just a second. So let me do that for us. And we're going to do some more complex ones. So I'm going to pull it up here. And you might see some new rules appear here. Don't worry about it. Because we're on this page, we're told to use these definitions, which means even if you thought that that symbol represented something else before, we're going to use the current definitions. Let me just double check that I've addressed any questions here. You did the same answer, just wrong symbol. Yeah, it happens, which is why we're always cautious to always check our work afterwards with every math question. Beautiful. So hopefully we're all caught up here. Let's go back to our PDF. And we're going to look at the first question here. We'll look at the definitions in just a second. So we're just going to be super careful here. There's only a few questions, but they're a bit longer, and they're a combination of a bunch of these rules. So let's take a look at the first one. So the first one here, if I just write down a 1, tells me I have a 2. I have this, almost looks like addition, but it's probably not that. I'll find out in just a second. So I'm just kind of drawing it out here with the 1. Then I have some strange symbol that has PWR in here. I believe that stands for power. But right now I don't really care too much. And rather than me writing out the next question, I'm going to address this one first. So let's see. I'm looking for this symbol and this symbol. Everything else looks familiar to me. These are just brackets, probably just to separate what's happening between whatever this number is and the 2. And the rest of them are just numbers. So I feel confident that that's all I need. That's all the information I need. Let's jump to the top. And according to the order of operations, I really want to work with my brackets or my parentheses first. So let's find out what this amount is equal to. And I'll use my green for that here. And have I found my operator just yet? Yes, it's at the very top. And here's a perfect example how a really long rule can be really summarized with one symbol. Because when I have this symbol, look at what I have to do. I take my first number, I multiply it by my second number. I then have to subtract my second number raised to the power of 2. And I then have to do more. I have to subtract my first number divided by my second number raised to the power of 2. Oh my goodness, that's a lot of work to do. So we'll do that in just a second. Let me put brackets around that. Because when I find that answer, I have to work with this symbol. What does this symbol tell me to do? Well, right beside it, I see it on my document, that I take my first number, which will be whatever this result is, and raise it to the power of my second number, which is a 2. So if you need to, pause the video here and really think hard about what I'm going to write down in a second. So this symbol tells me to take my first number, which will be the result of this, and raise it to the power of my second number, which is a 2. So all I'm going to do is include a 2 there, an exponent of 2. Okay? Hopefully you're following along there. So now I'm going to carry out those operations. So let's see here. Let's bring in another color just so we don't get confused. So here I get a 2. Here I get a 1. Here I get 2 divided by 1. We've talked about that before. It's just a 2. And let me just take care of this exponent as well. 2 to the power of 2 is a 4. Which means I get 2, right? 2 minus 1 minus, this whole thing was a 4. And I raise that to the power of 2. That looks a lot nicer to work with. Let's just go left to right. 2 minus 1 is a 1. 1 minus 4. Aha, I'm getting into my negative numbers here. So one more time, that's 1 minus 4. I get into negative 3. Hopefully I did that correctly if you guys are following along. And if I do that, if I raise a negative to the power of an even number, I'm going to get a positive. And if I take 3 to the power of 2, I get a 9. All right? I love that you're trying, everybody. I really appreciate it. Even if your answers are wrong first, don't worry about it. Practice makes perfect all the time. All right? Which is why you can look at the follow-along worksheets afterwards, try them again for yourselves, and then also try the practice sheet. Okay? And for those of you that aren't familiar with integers, like I said, that's just something else you might have to catch up on before you approach some of these questions. Let's do one more. I don't want to keep you guys here too long, but let's jump to the last question on this page. So I'm going to remove this. And I'm going to scroll down to the last question here, which, let's see if it's difficult or not. Look at that. We've had quite a few operations here. So, first things first, Sandra needs to practice her artistic skills and copy this out on her whiteboard. Let's see if she can do that. Open up a bracket, draw the symbol, dot, 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 1, 1, 2. Okay, looking good so far. Another symbol, the power 1. It almost looks like it's a button on a calculator I'm supposed to press. Except I'm pressing it up here in my mind. Open up a set of brackets, draw a triangle, 2, 2, 2. All right, I'm ready to go. I need to look for 3 symbols. I need to look for this guy here. I'll just color it in red. This guy here, and this one here. So if I do that, let's take out my blue marker. Let's just carry on with those 2 sets of brackets first, and then we'll work with this middle operation. So if I do that, I need this symbol, which had 3 dots within it. So I'm searching, searching, searching. Aha, I get it. It's just at the bottom there. And it tells me to open up a set of brackets, take the first number, raise it to the power of my second number, add to that my third number, raise it to the power of my second number, raise all of that to the power of 2. Whew, that's a lot. Then I have this symbol, so I can either write this out or I can include whatever that is, whatever that rule is right away. So let me just double check what that was again. It was raising this first number to the power of whatever this is. So I could do that. I don't have a lot of space, so I would really be tempted to do it if I wasn't doing this on the Schoolhouse lesson. But I don't want to confuse you guys, so I'm not going to try to squeeze it into here. I'll leave this symbol for now and take care of this result here. And coincidentally, it's already on the screen. When I have this triangle, I am told to take the first number, which funny enough, all of them are 2s. So first number to the power of the second number, plus third number to the power of the second number, all over that second number. So let's find these numbers first. I'll use my green here. Let's just double check the comments here, make sure none of you guys are lost here. It is a lot, right? We'll end right after this question. So let's do this hard work and then we'll feel really good about ourselves. What do I get here? Well, lucky for us, 1s are easy to work with. 1 to the power of 2 is a 1. 1 to the power of 2 is a 1. 1 plus 1 is 2. Let me erase that. 2 to the power of 2 is 4. Hopefully you're following along here. All of this gives me a 4. Let's jump to these brackets here. I'm only erasing it because I don't have a lot of room. 2 to the power of 2 is a 4. Let me squeeze that in here. Again, 2 to the power of 2 is a 4, so I have to add this. And then I have to divide it by a 2. So let's take care of the addition first. 4 plus 4 is 8. I'm going to write that in here. And what is 8 divided by 2? I get 4. And I totally agree with my helper here. Some of you might find a really fast way to do this, and you don't need to go through all these individual steps. And if that's the case, go ahead and do that. That's absolutely true. I just want to make sure we're all on the same page here. So now I'm left with 4 with this symbol and then a 4 here. So I'm going to help myself out and just write that all here. Again, if you catch me making a mistake, it's your responsibility to tell me. All right, if I have 4 with this symbol in between it, it means that I take my first number and I raise it to the power of my second number. And so then I'm left with 4 to the power of 4. Thank you. Just as I finished writing that, I got the answer in the comments. It is equal to 256. Yay! A lot of work to be done, but when you do it at a pace that works best for you, meaning you're making sure that you're substituting the right numbers into the right variables and you're using the order of operations correctly, I promise you will get to that right answer. I'm going to end it off there. I'm just going to repeat myself one more time. There is a follow along worksheet that you can use. Go back to this lesson, follow along. And then a practice page just at the end of that document to have a little bit more fun doing these as well as a challenge question to really challenge yourself with, right? I hope you guys had a lot of fun. If you'd like more questions like these, you know who has them. It's your nearest Mathnasium. Reach out. If you want to follow up on some of the answers, go ahead and reach out to them. I know they'd love to help you out. Our instructors love doing these types of things. So, and if you're curious on any other extension topics beyond what you learn in the math classroom, again, reach out to your nearest Mathnasium, and I know that they'll have a lot more for you. Rula, I think you're in a parent account, so I apologize if that's not your student name, but I'm so happy to see that you're having a lot of fun. All right, guys, have a wonderful day, and smile loads, and we'll see you tomorrow on our next Schoolhouse lesson. Bye-bye.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.